Here, the name of the experiment is RP of Prism, means resolving power of prism. You have to determine the resolving power of a prism by using spectrometer. That is the aim of our experiment. Now, what you will require? Spectrometer you will require for that. You will require a mercury source. So this is a mercury source provided. Then prism you will require, double dense prism, a flint glass prism is given, right? Then adjustable slit you will require in the next part of the experiment, and traveling microscope. This is the apparatus which is required for the experiment. You know that when you are doing the experiment in using the spectrometer, you should do the preliminary adjustment of the spectrometer. How we do that? First step, leveling of the tables. With using this spirit level, you can level the collimeter. This is called as a collimeter. Put it here, use this screw, and bubble should be at the center. Then put it here, use this screw, then this bubble should be at the center. Leveling of the collimeter, leveling of the telescope. Then level the prism. Here you put it this way. By using these screws you can adjust. This way you can see that it is at the center. Then here also this prism table you can level by using this. Here you put this way. This way you can. This is the very primary adjustment of the spectrometer. Step 1. Then open the slit and focus the color. Slit should be, width of the slit should be narrow. How will do that? Here you can see. Again adjust it now. Now first you see it should be in front of the source. See this way to do. All of you will see one by one. After focusing the color, light on, shooting. See, all of you see that. Now see that image of the slit through the telescope. It should be at the vertical cross wire and it should be fine. You can focus the telescope and make it sharp. Alright? Let us see. Okay. See, this is the second step you have to do. Then take the prism, double dense prism, and this is the base of the prism, right? Base. These are the two refracting surfaces. Now put the base of the prism towards you. The light will come. It will fall on the two refracting surface. It will fall on the first refracting surface. Light will get refracted through it, and after refraction, the dispersion of light will take place, and you will see the spectrum, right? So you should see from this side now because your base is here. Now let us rotate this. Now light will switch on and see the spectrum. This way the spectrum will come. Clear spectrum. Now when separated, two yellow lines are getting there, then blue line is there, green line is there. For these four colors, you have to determine the delta M, angle of minimum deviation. Now once you do this spectrum we got, obtain the position of minimum deviation. Minimum deviation means you will see the spectrum or yellow line. As you rotate the prism table, it will move on one side, it will stop there momentarily and then returns back. So that position where it stops, that will be a position of minimum deviation. Right? So that is a position of minimum deviation. So I will show you that minimum deviation. So open the prism table and rotate it. एक मिनिट सर्वजण रोटेट करून बघा. You rotate it, that will move. It will stop and it will go back. That is the minimum deviation. Then you stop the prism table, rotating, fix the prism table. Thereafter, don't rotate the prism table. But you have to do the Schuster's method now. What is that I will explain. समझे राज? Got it? का नाही? तो फिरवला ना तर ती जो स्पेक्ट्रम एका बाजूला जातोय असा थांबेल तिथे आणि तो इकडे जायच्या ऐवजी तो परत इकडे जायला. दॅट इज द मिनिमम डेविएशन. राईट? परत बघूया. Now minimum deviation you got, but spectrum should be clear throughout the field of view. When you go to the left or right, the spectrum should be sharp. So in order to make it sharp, Schuster's method you know. What is that method? Rotate the prism table toward this side, adjust the television. Rotate the prism table toward that side, adjust the collimator and make the spectrum sharp. Once it is sharp, then at the minimum deviation position, you will clamp the prism table. Clamping of the prism table is must before starting the reading. Once you clamp it, then take the yellow one line on vertical cross line. Alright, so I will do that. I have rotated it this way, I will adjust this. I will rotate it this way, I will adjust this. Alright, now here cross of the crossbar should be taken. I will fix the prism table. Now it will not move. I will take the cross of the crosswire on yellow one. This also you fix, and by using the slow motion screw you can shift. Now yellow one line is on vertical crosswire. The two windows readings you have to take. Take the reading. One sheet is given. You take the sheet. You take the sheet. Yes. Okay. Reading the sheet. Both the windows. Alright? Both the windows mean here now see least count of the spectrometer, smallest division on the main scale 30 minutes half degree, and total number of vernier scale is 30. This is vernier scale. How many are there? 30 are there. So 30 minutes upon 30 minutes least count is 1 minute. Right? Then reading on the spectrometer. Now when you will see 3 by using lens, use the lens. Don't see directly, you will not able to get it. So lens you will use, you will see this type of a main scale, this type of a vernier scale. Now this zero of the vernier scale, where it corresponds, that will your main scale. Now here you see what is the reading? 230. One small line is there, means 230 degree 30 minutes. That is your main scale. Then out of these 30 lines, this 19th line you can see is exactly coinciding here. That number you have to write. Then what will be total reading? Out of this 10, 11, 12 like this way, this will be 19th line. It will be exactly coinciding, and that number into least count. 19 into 1 minute means 19 minutes. Now add that 230 degree 49 minutes will be your X window. Then you take the Y window for yellow one color. Y window, here you have to see what is the reading, and the same way you have to take the reading. Right? Yellow one, then by using this slow motion, you take yellow 2 on the vertical crosswire, then you go to the blue, green, then you go to the blue. 4 colors readings you have to note down. Yellow 1, yellow 2, green and X, Y, X, Y, X, Y, X, Y. All these readings you have to take. For one color, 2 readings will come. One X window, another one. If you take it accurately, then remove the prism, take the direct reading. Direct reading means what? On vertical crosswire, that white line you are getting, the image of the slit. That position you have to note down X and Y. X and Y you have to note. What it is actually then? This is direct reading. Yellow one you will note down, yellow 2, green and then blue. This is your direct reading. Each reading minus direct reading will give the angle of minimum deviation. So here this will be delta theta y1, this is theta y2, this is theta green, this is theta. Now from yellow one to green or blue, angle should go on increase in direct reading इथे, yellow one color इथे, yellow one will be here, yellow two, green, blue, angle will go on increase. So when you take the reading, you should see that. Otherwise, one reading increases, one reading decreases, means something you are doing wrong. Got it? Yes. So this way you can see from the diagram how it is. Alright? Then the difference how you will take. You got the means all four color readings and direct reading. Each reading you will subtract from the direct reading. How it is? Suppose here see X window reading and Y window reading. Suppose your reading is 61 degree 5 minutes and this is 12 degree and 57 minutes. How will take the difference? 61 degree and a 5. And the 5 minus 57 is not possible. So what I will do then? I will write it as 60 degree and 65 minutes. 1 degree means 60 minutes. So that 60 minutes will be converted here into 60 plus 5, 65, and I can subtract the 57. Right? 65 minus 57 is 8 and 60 minus 12 is 48. Yes. You got it? How the difference you have to take? Here also the same directly you can take. Directly 7 minus 2 is possible. Then 11 minus 3, you will get the 40. X reading, Y reading. Here they are coming near about same. The one angle of deviation shown by X window and another by Y should be same. At the 48 and 8 don't say. Don't say how it is possible. Have you got it? Yes. Now start taking the reading. Got? तिकडनं ॲडजस्टेबल स्लीप घेऊन करा तुम्ही. It is an adjustable slip. Keep it widely open first, right? And attach it here. Now when you will attach, you will be able to see the two yellow lines well separated. Now once you fix it here, these are the screws. By using these screws, you can do that adjustment. Now can fix it here. Make the slit vertical and tight it. Right? Now decrease the width of the slit. One stage will come. The two yellow lines will start merging. Merging means what? Ekatra hona. Two are well separated. Now they will start just merging. That time you remove this slit and put the below the traveling microscope. Measure the width of the slit. Yes, width of the slit using the traveling microscope. Then second step, keep it closed, completely closed, and then go on opening it. As you open, you will see only one line. Why? Because two lines are merged. Now one will become two, just separated. That position you have to take the width of the slit. Means one line will just appears to become separate, not well separated. Remember, this is important. Two lines will become one, just starts merging and just starts separating is very important. I think what our students are doing, they are adjusting it such that two lines have become one. That we don't require. Just they are becoming one, that width of the slit is required. These two readings of the width of the slit by using traveling microscope you have to take. Once you know that, you can find out the refractive indices for 4 different colors and the formula is given. By using those formulas, you can determine the resolving power of the prism. Alright? So here the B1, B2 by this formula is given this. Alright? Now here the wavelengths are given. By using the wavelength and the refractive indices which we have obtained, you can find out B1, you can find out B2, you can take the mean of that and B1 plus B2 by 2 is B. Then d mu by d lambda, change in refractive index with respect to wavelength 2b upon lambda. Keep lambda means mean of the yellow colors. Mean means average of these two you take and write it. Then W equals to 2a width of the slit, sine of alpha by 2, alpha 60 by 2 means 30 here. Alpha plus delta m is the angle of minimum deviation for mean yellow color here. Okay, Substitute that, you will get W, and W into 2 mu d mu by d lambda, that will be the resolving power. Experimentally you will obtain it. Theoretically it is given by lambda upon d lambda. Lambda means mean of the yellow color and d lambda means difference of the wavelength of the yellow color. So that will be lambda upon d lambda, and it is 275. Answer. Theoretically. Experimentally what you get, you see. If they are coming near about same, this your experiment is fine. Alright. So start and do it. Graph of the